Karnaugh map. A Karnaugh map is a graphical method to reduce the number of terms in a Boolean expression representing a circuit. It was introduced by Marie Curie in 1953. This method is usually applied only when the function involves 6 or 4 variables, but today we will discuss the Karnaugh map to simplify the Boolean expression involving 2, 3 and 4 variables. For a Boolean function of n variables, the Karnaugh map will have 2 raised to power n squares representing min terms of the Boolean expression. Each square contains either 0 or 1. The value 1 in a square represents a product term present in the expression, otherwise 0 is written in the square. When a Karnaugh map has been filled with 0 and 1, the sum of product expression for the output can be obtained by looking at squares that contain 1. So we can say that Karnaugh map is a pictorial representation of truth table of the Boolean functions. So first of all, we will discuss the case of two variables. Suppose we are given a Boolean function f equal to xy plus x dash y, and first of all we make a table. In the extreme, on the top border row, we represent x and its complement, and in left border row we represent y and y dash. Here the number of variables is 2, so number of squares is 2 square means 4. So 1, 2, 3 and 4. So first of all we will construct a table. So x into y is xy, x into y dash is xy dash, x dash into y is x dash y, and x dash into y dash is x dash y dash. In the table, in the given Boolean function, we have xy and x dash y. In place of xy, we write 1. In place of x dash y, we write 1. We don't have xy dash in the given function, so I have written 0 here. We don't have x dash y dash in the given function, so I have written 0 here. So two adjacent square xy and x dash y containing 1 have been enclosed by the rectangle. This is a rectangle which represent xy and x dash y. This one. This is the rectangle. These two terms can be looped to give a resultant that eliminate x, since it appears in complemented and uncomplemented form. So this rectangle is equivalent to y, because on the extreme left side we have y here. So we have simplified the Boolean function f equal to xy plus x dash y to give y. Now one more example. Use a graphical method to find the minimal disjunctive normal form or sum of products form for the following functions. First one is xy plus xy dash. So first we will construct a table. So x into y. We have xy here, so I have written 1 here. Then x into y dash. We have x into y dash here, so I have written 1 here. Then x dash into y. So x dash y is not there, so I have written 0 here. X dash into y dash. X dash y dash is also not there, so I have written 0 here. So here in this case, we have only one rectangle, which is a vertical rectangle. This one. This is a vertical rectangle of ones. This one. This one. And here on this side we have y in complemented and uncomplemented form. So this gives only x, because in the top row of this vertical rectangle we have x here. So this xy plus xy dash is equal to x in minimal disjunctive normal form or sum of products form. One more example, we have x phi, x dash phi plus x dash y dash. So for this, first term is x into y. We have xy here, so I have written 1. Then x into y dash. We don't have xy dash here, so I have written 0 here. Then x dash y. X dash y is 1 because we have x dash y here. Then x dash y dash. X dash y dash is 1. So here we have two rectangles. One is this horizontal rectangle containing 1, this one, and another is this vertical rectangle containing 1. So in this case we have two horizontal rectangle has one vertical rectangle, this one, and one horizontal rectangle. So horizontal rectangle gives y because here we have x in complemented and uncomplemented form, and vertical rectangle give x dash because in this side we have y and y dash in complemented and uncomplemented form. So uh, the given Boolean function xy plus x dash y plus x dash y dash reduces to x dash plus y because this rectangle gave y and this rectangle gave x dash. So x dash plus y. Now one more example, xy plus x dash y dash. So here x into y, xy. So this is 1 here. X into y dash, xy dash. We don't have xy dash, so I have written 0 here. Then x dash into y. We don't have x dash y here, so it is 0. X dash y dash, so it is 1. X dash y dash means 1. Now we observe that the given function consists of two isolated square. One is this square and one is this square, which represent xy and x dash y dash. So this function from this function the resulting function is xy into x dash y dash, and it is the minimal form of this function. Because we always consider either horizontal rectangles or vertical rectangles, we never contains diagonal elements. So these elements are in the diagonal. So we have considered this square and this square. This square is xy and this square is x dash y dash. So in this case we have only two isolated square which represent xy and x dash y dash. Now one more example, AB dash plus A dash B plus A dash B dash. So AB dash, AB, we don't have AB, so it is 0. AB dash, AB dash, this is AB dash, so 1. A dash B, here if we have A dash B, so it is 1. A dash B dash, so it is A dash B dash, this is 1. Again here we have two rectangles. One is this horizontal rectangle of 1's which gives B dash, and one is this vertical rectangle of 1, this gives A dash. So the resulting function is A dash plus B dash. So after simplification using Karnaugh map we get AB dash plus A dash B plus A dash B dash is equal to A dash plus B dash. Now the case of 3 variables. 3 variables means 2 raised to power 3. We have 8 squares. So 1, 2, 3, 4, 5, 6, 7 and 8. In case of 3 variables, in each Karnaugh map we have 8 square. In the top order row we write xy, xy dash, x dash y dash, x dash y. Take care of order. I am changing one at a time. So it is xy, x is kept constant, y is changed to y dash. Then next y dash is kept constant, x is changed to x dash y dash. In next case, x dash is kept constant and y dash is changed to y. And here z and z dash. So in the top border row, be careful about the order. Change only one variable at a time. So xy, xy dash, x dash y dash and x dash y. So be careful about the order of these variables. Here it is z and z dash. Now we will construct a table as we constructed for two variables. So first is xy z. So this is xy z. So it is 1 here. Next xy z dash. We have xy z dash. So it is 1 here. Xy dash z. We don't have xy dash z here. So it is 0. Xy dash z dash. Xy dash z dash we don't have here. So it is 0. X dash y dash z. X dash y dash z. So it is 1 here. X dash y dash z dash. We don't have x dash y dash z dash here. So it is 0. X dash y z. We don't have x dash y z here. So it is 0. Again x dash y z dash. X dash y z dash it is 1 here. So we have constructed a table. Now we will look at ones. So we have this rectangle 1 of containing 1. So this rectangle gave, here we have z and z dash in complemented and uncomplemented form. So here it will give xy. In the top border row we have xy. So this rectangle gave 1. Beside this we have this term. This is isolated square. So this isolated square gave x dash y dash z. So x dash y dash z. We have 1 here and 1 here. So we will consider this column and this column as adjacent columns, because we can wrap them around. We can join this and this. We can wrap them around. So we will consider this last column and this first column as adjacent columns. So here it is x dash y and x dash y dash z. Here it is x y z. So here we have x dash y and this is xy. So x and x dash are in complemented and uncomplemented form. So we are left with y. And this side we have z dash. So y z dash. So this rectangle, which is vertical rectangle, gave us 1, gave us xy, because here we have xy, and this horizontal rectangle, here we have 1 and here we have 1, because we are considering this column and this column as adjacent columns. So we can join this and this because we can wrap them around. So because this can be joined with this if we fold the paper. So here x and x dash are in complemented and uncomplemented form, and we are left with y, and here it is z dash. So it is y z dash, and this is isolated square. So it is x dash y dash z. So xy plus yz dash plus x dash y dash z. Now one more example, xyz. xyz. So it is 1. Next is xy. Next is xyz dash. So this is xyz dash. So I have written 1 here. xy dash z. So it is xy dash z. So 1 here. xy dash z dash. We don't have xy dash z dash. So it is 0. X dash y dash z. X dash y dash z. So it is 1 here. X dash y dash z dash. We don't have x dash y dash z dash. So 0. X dash y z. So it is x dash y z, it is 1 here. X dash y z dash, we don't have x dash y dash z dash, so it is 0 here. So in this case we have only two rectangles. One is this largest rectangle of ones, which will give us z, and another is this vertical rectangle. Another is this this one. Another is this vertical rectangle. So this will give us xy. So this Boolean function is equal to xy plus z. We always consider largest rectangle. So the largest rectangle is this rectangle consisting of 1 1 1 1 1, and always remember that this should be even power, means 1 2 3 and 4. So this is the largest rectangle consisting of 4 square, and the extreme left we have z. So this will give us z, and this vertical rectangle 1 1, this will give us xy. Now one more example, this is xy z. xy z, this is 1. xy z dash, xy z dash, this is 1. xy dash z, we don't have xy dash z here, so it is 0. xy dash z dash, this is not available, so it is 0. x dash y dash z, so this is 1 because x dash y dash z. x dash y dash z dash, it is there, so it is 1. x dash y z, x dash y z is 0 because it is not there. x dash y z, so it is there 1. So in this case we will have as it is clear, 3 rectangles. One is this vertical rectangle, and this vertical rectangle gave us xy, so it is xy. Another is this vertical rectangle, this gave us x dash y dash, so x dash y dash. And another is this rectangle. In this rectangle we have y and y dash in complemented and uncomplemented form, so we have only x dash. This side we have x dash, and here we have z dash. So in this horizontal rectangle gave us x dash and z dash. We don't consider y because it is in complemented and uncomplemented form, so we remove it. So it is x dash z dash. So this is xy, x dash y dash, and x dash z dash. But it will give one more minimal form, because this column and this column can be considered as adjacent columns because we can wrap them. So this number and this number, when we join these, can be considered as a rectangle. So here we have x dash y, here we have xy. So x and x dash are in complemented and uncomplemented form. Here we have y, here we have y, so y z dash. So it is y z dash. So in this case we have two minimal forms. One is xy, x dash y dash, x dash z dash. Another is xy, x dash y dash, and y z dash. Always remember that last column and this column can be considered as adjacent columns, and this row and this row can be considered as adjacent rows because we can always wrap them. Now the case of 4 variables. So here in the 4 variables we have to find the minimal form using Karnaugh map. So first question is x dash y z w, x y dash z w dash, x dash y dash z w dash, x y z dash w dash, x y dash z dash w dash. Here we have 4 variables, means 2 raised to power 4. So 2 to the 4 to the 8 to the 16. So this Karnaugh map contains 16 square, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So now we will construct a table as we constructed for 2 variables and 3 variables. So here we will write xy. Remember that we will change only one variable at a time. xy, x, y dash. We have changed y dash. Then x dash, y dash. We have changed x dash, x to x dash. Then x dash y. We have changed y dash to y. Here also we have 2 variables this time. zw, then zw dash. We have changed w to w dash. Then z dash w dash. We have changed z to z dash. Then z dash w. We have changed w dash to w. So here xy, xy dash, x dash y dash, x dash y. Don't change this order. zw, zw dash, z dash w dash and z dash w. Now we will multiply. X, Y, Z, W. We don't have X, Y, Z, W here. So 0. X, Y, Z, W dash. We don't have X, Y, Z, W dash here. So 0. X, Y, Z dash, W dash. X, Y, Z dash, W dash. So it is X, Y, Z dash, W dash. So 1. X, Y, Z dash, W. We don't have X, Y, Z dash, W. So it is 0. X, Y dash, ZW. We don't have X, Y dash, ZW. So 0. X, Y dash, ZW. X, Y dash, ZW dash. This term. So it is 1 here. X, Y dash, Z dash, W dash. So this is there. So 1. X dash, Y dash, Z dash, W dash. X, Y dash, Z dash, W. We don't have. So it is 0. X dash, Y dash, ZW. We don't have 0. X dash, Y dash, ZW dash. X dash, Y dash, ZW dash. This term. So it is 1. X dash, Y dash, Z dash, W dash. So it is 0. We don't have X dash, Y dash, Z dash, W. So it is 0 because we don't have X dash, Y, ZW. So it is 1. X dash, Y, ZW. X dash, Y, ZW dash. We don't have 0. X dash, Y, Z dash, W dash. So it is 0. We don't have X dash, Y, Z dash, W. We don't have, it is 0. Now we will look at ones. So we have, clearly we have 3 rectangles. One is this rectangle. This rectangle gives y dash and this side we have zw dash. X is in complemented and uncomplemented form. So this is y dash, this is zw dash. So y dash, zw dash. So this rectangle gave y dash, zw dash. Another is this rectangle. This rectangle gave here x and this is z dash, w dash. X, z dash, w dash, because y is in complemented and uncomplemented form. And this is isolated square, and this isolated square is x dash y zw, x dash y zw. So this is, here in this case we have 3 rectangles. One is this rectangle. This gives y dash, zw dash. One is this rectangle. This gives x, z dash w. And one is this isolated square, means x dash y zw. Now these terms. For these terms, we will construct a table, Karnaugh map, like previous examples. This is x, y, z, w. We have x, y, z, w here. So it is 1 x, y, z, w dash. X, y, z, w dash. This term. So it is 1 here. X, y, z dash, w dash. We don't have 0. X, y, z dash, w. We don't have. So this is 0. x y dash z w dash zw, sorry, x y dash zw, x y dash zw is this, so it is 1, x y dash zw dash, so this term, so it is 1 here, x y dash z dash w dash, so x y dash z dash w dash, so this term, so this is 1, x y dash z dash w, so this term, so it is 1, x dash y dash zw we don't have, so it is 0, x y dash zw dash, so it is 0, we don't have, x dash y dash z dash w dash, all 4 dashes, x dash y dash this term, so this is 1, x dash y dash z dash w, so this term, so this is 1, x dash y zw, x dash y zw, oh sorry, we don't have, so it is 0, x dash y zw dash this term, so it is 1, x dash y z dash w dash, so it is 0, x dash y z dash w, so it is 0. So in this case we have this rectangle consisting of 4 squares, 4 ones, this one, this one, so from here we get x and z, because y is in complemented and uncomplemented form, w is also in complemented and uncomplemented form, so from here we get x, from here we get z, so one square is consisting of this 4 ones, 1 1 1 1, so this is 1, this one, another is this one, here also x is in complemented and uncomplemented form, so we are left with y dash, and this side w is in complemented and uncomplemented form, so we are left with z dash, so this from here y dash, from here z dash, so y dash z dash, so another is this one, this is the last column and this is the first column, this can be wrapped around, so this one can be combined with this one, this can be considered as one rectangle, this one and this one, so here x and x dash, so x is in complemented and uncomplemented form, so we are left with y, and this is zw dash, so y zw dash, so from this rectangle we got xz, from this rectangle we got y dash z dash, and from this rectangle this one and this one is this, another is this, from these two ones because we can wrap them around, this is the last column and this is the first column, so this can be considered as one rectangle, so here from here this is y and zw dash, so y and zw dash, so we have, in this case we have 3 rectangles, so this whole expression uh, is reduced to xz plus y dash z dash plus yz w dash. Thank you.